A capacitor consists of two large metal discs with a radius of 1.1 meters placed parallel to each other a distance of 1.2 millimeters apart. The capacitor is charged up with an increasing amount of charge Q on the disc and negative Q on the other disc. At what value Q does a spark appear between the two discs? Well, in order to solve this, we have to find the function for an electric field for a single disc. But a disc can be thought of as a series of very small rings layered one on top of the other. So the equation for a single ring is as follows. 1 over 4 pi epsilon naught times Q, which is the charge, Z, which is the Z-axis, times R hat over R squared plus Z squared to the 3/2 power. Now, we know that R hat is 0, 0, 1 because the X and Y components cancel, leaving only the Z. So as we move along the disk, the charge changes as does the electric field, leaving us with delta Q. Well, delta Q is Q times the area of the ring over the area of the disk, which is 2 pi r delta r over pi r squared times Q. Just plugging that in for delta Q, we can cancel a few like terms here and here. This can be pulled outside, and that leaves us with this. Times R delta R. Now that we have this, we can integrate from the center of the disk to the very outer edge of the disk. I've already set up the integral. All of these are constants and can just be pulled out directly, leaving us with this. After using U substitution or integral table, whatever is most comfortable for you, we are left with this value. But as you get very close to the disk, like a millimeter, Z gets closer and closer to 0, causing these values to get closer and closer to 1. And that leaves us with this. A is the area, which is pi r squared. So now what we want to do is we want to find the charge in order to create the spark. And as mentioned before, a capacitor is like two disks placed close to each other. The internal electric field is the sum of the two disks. We already solved for the electric fields of a disk, so we can just plug those in. The sum of these two is just simply Q over A over epsilon naught. Now, A is the surface area and is equal to pi r squared, as we had plugged in before. We just plug that back in and get this. Now, around 3 times 10 to the negative 6 coulombs, the air in the capacitor will begin to break down and create sparks. Now, we just plug in the values that were given to us earlier, and we could just solve for the charge Q. So we have 3 times 10 to the 6th coulombs times 9 times 10 to the negative 12 coulombs times pi times 1.1 meters squared, which gives us Q, which is 1 times 10 to the negative 4th coulombs. And that's when sparks will be made.